Hello everyone. Today we are going to solve the second question of CP31 sheet, which is called as line trip. So let's go. Okay, so I have this question in my whiteboard. Let's solve it. Let's start by first understanding the question. So there is a road which can be represented as number line. You are located at in the point zero on the number line. Okay, so there is a number line. We are located on a zeroth position, and you want to travel from point 0 to the point x and back to point 0. We have to go from point 0, just point 0 to point x and return back. Okay, so you travel by car which spend 1 liter of gasoline per 1 unit of distance traveled. When you start at point 0, your car is fully fueled. Its gas tank contains the maximum possible amount of fuel. Okay, so at the starting position, your gas tank is full, and the charges are the charges 1 gasoline per 1 unit distance. Okay, there are n gas stations located at point A1, A2 to AN where you arrive at gas station. You fully refuel your car. Note that you can refuel only at gas stations, and there are no gas stations in point 0 and X. There will be no gas stations at point 0 and X. Okay. And there will be gas stations to point A1 to AN which are in between 0 to X. Okay, so suppose this is A1, this is A2, and so on. This is suppose AN. Let's write it in good way. Charges. Okay, so you have to calculate the minimum possible volume of gas tank in your car that will allow you to travel from 0 to point X and back to point 0. So what should be the minimum gas tank size? Gas tank. So you can pause the video and think about it. So let's suppose we fueled our tank at 0th position. So we should have at least A1 minus A0, A1 minus 0 size of tank because we have to travel the distance of A1 units from here. So at least A1. From A1 to A2, we should have the fuel tank of size of at least A2 minus A1 and so on till AN. From traveling from AN minus 1 to AN, we should have the tank of at least size of AN minus AN minus 1. So, you can think of it as suppose let's take a test case that I am at 0th position. I want to reach at 7th position. So I have the gas station at 2, 5, and 6. So to travel from 0 to 2, I should have the gas tank of size of at least 2. So that when I reach here, I can refuel my tank fully, and I have to travel to the next station. So from traveling from 2 to 5, I should have at least 3 sized fuel tank. For traveling 5 to 6, I should have at least one size full fuel tank. For traveling from 6 to 7, I should have one, one sized fuel tank. But one condition here, that they said there will be no fuel tank at the last position and the first position. Okay, so for traveling to the last position from second last position, we have to travel this distance and this distance as well, because we have to get back to zero as well. See, they said here that you want to travel from zero to the point X and back to zero. Okay, so for the last distance, we have to calculate. Suppose the last distance is D. So we have to consider it as 2 into D for the tank fuel size, because he has to go from second last point to the last point and from last point to the second last point. So this should be the minimum size of fuel tank. So what we can do? So here for traveling this segment, we should have distance of into D, 2 into D, considering this as the D distance. So this should be the minimum fuel tank size to travel this segment completely. From traveling from here, it will be 1. For traveling back from here, it will be 3. So a quick observation here that for minimum fuel tank size to complete this task of going from 0 to X and to back to 2, we should have the minimum fuel tank size of maximum of 2, comma 3, comma 1, comma 2 into D. Getting it? Let's take the example. Let's take the test case. Okay, so first test case is 3 and 7 and 1, 2, 5. Okay, so we will be starting from 0. There is a fuel tank at 1, at 2, at 5, and at 7. No, there is no fuel tank at 7, but we have to reach 7 and get back to 0 as well. So from reaching it to here, we require at least one unit of gasoline size, gas tank size. From here to here, we need at least one gasoline tank size. From here to here, we'll need at least three sized fuel tank. From here to here and here to here, we need 2 into 2 sized fuel tank, because there is no fuel tank at the last position. So we should have at least uh, four four sized minimum gas tank. Okay, because if we have less than four sized gas tank, which is the maximum among all this, then we won't be able to cover this segment. Okay, so we got the intuition with the observation of this question. We got to know that the answer will be the maximum distance between these segments and the last segment into 2. Okay, so the answer will be maximum of AI minus 1. This will be the answer, and after that answer equals to max of answer, comma 2 into D, and D is basically the last segment distance. This was the intuition of the problem. So let's see how we are going to code this problem. Okay. So we will take an vector where we will put the 0 as our first position. Then we will put all the gas stations. Suppose in this test case 1, 2, and 5 was there, and we will in the last will put our destination 7. After that we will take their differences till the second last, and we will take the maximum from those. Okay. Uh, it will be okay even if you don't take this destination. Uh, so after taking the maximum distance, we have to compare. We have to take that max. Suppose it came out to be D1, and D is the distance between destination and the second last gas station. I mean the last gas station. I mean this. Okay, so that distance will be 2 into D for the fuel tank. At least this much fuel tank will be needed to cover the last segment. So our answer will be maximum of D1, comma 2 into T. Okay, so let's code it. Here are the test cases. So let's code it. Let's first write down the boilerplate. So let's take the input. First input is T, that is number of test cases. So we will be iterating over each test case. So first, the input for the first test case is n and destination, and n destination. Let's take the input of both. After that, we have n gas stations. We have given the location of n gas stations. So let's make the vector of n size to n. We will do one thing. We will first put the zeroth position in the vector. After that, we will put all the gas stations position in the vector, as we discussed in the approach. We index dot. Okay. So after that, we will initialize the answer equals to int min, as we are going to take the maximum between two consecutive things. So we will take int I equals to 0, I plus 1 dot v dot size. I am taking v dot size here because we have the size of vector as n plus 1 now. Okay, so let's take the answer equals to max of answer comma v of I plus 1 minus v of I. Okay, and in last, as we discuss about the last segment distance will be, uh, we will require 2 into destination minus the last station, and the answer will be the maximum of both answer comma D. See out answer. So let's say if it works or not. Okay, so it's passed. So let's submit this question. Okay, it got accepted. So thank you everyone. If there are any doubts, you can comment down them. I will try to answer them. Thank you.